Hi everyone! In this video, we will find the product of rational expressions. Multiply 6b over the quantity b squared plus 11b plus 24 times b squared minus 64 over 5b. When we multiply fractions, we multiply numerator to numerator and denominator to denominator, and then we must simplify. However, we can simplify before we multiply, and this makes it a little faster. So let's go ahead. To simplify a rational expression, this means that I must have the same factor in a numerator and a denominator to cancel out. Because I have terms in both the numerator of the second fraction and the denominator of the first fraction, I need to factor these first, and then I can have factors that can cancel out. So let's go ahead and we will factor the numerator of the second fraction. So I have a square minus a square. This follows a pattern, and to factor it, it will factor into two binomials. And to find the terms for each of the binomials, we'll take the square root of the first term. Square root of b squared is b, and that becomes the first term of the two binomials. And then we square root the second term. The square root of 64 is 8, and that will be the second term of the two binomials. And then the pattern is one is addition and one is subtraction. And that is our difference of squares factored already. So now we can go ahead and factor the denominator of the first fraction. In this case, we have a trinomial, so we're going to need to use the AC method, or in this case, because the A is 1, we just need to find all the factors of C, or 24. So we will find a combination of those to give us the middle term of 11b. So let's go ahead and start by finding all of the factors of 24. 24 is 1 times 24. And now that we have all the factors, we need to look at the signs. The last sign is positive. This means that the signs of the factors are the same. They'll either both be positive or they'll both be negative. And then we look at the sign of the middle term and it's positive, so that tells us that they will both be positive, making them matching, and we can fill that in. Now that we have all of the factors, we're going to find a combination that will give us a positive 11. When I combine positive 8 and positive 3, I get positive 11. This means that I can replace the middle term with plus 3b and plus 8b. So we can rewrite this as b squared plus 3b plus 8b, and then finish it with the final c, which is 24, where we've replaced 11b with the two factors that we have found that add together to make our middle term. Now let's go ahead and factor by grouping because we have four terms. We'll group the first two and the last two. The first two, we're looking for the greatest common factor, and it looks like b is the only common factor between the two. So we have b plus 3. And then the next two, the greatest common factor is a positive 8, leaving us with b plus 3. Now we have two large terms, here and here, and we factor out again the greatest common factor. In this case, the binomial b plus 3 is in common with both of those. So we factor out b plus 3, which leaves us with b plus 8. Now we've factored the denominator of the first fraction and the numerator of the second fraction. Let's go ahead and rewrite this so that we can see it all together. We have 6b over b plus 3 and b plus 8. This is being multiplied to our factored difference of squares to be b plus 8 and b minus 8. And this is over 5b. Now that we have this factored, we can simplify it by finding any factors in common with the numerator and denominator, and they will cancel out. In this case, b plus 8 divided by b plus 8 is 1. And so those canceled out, and it looks like, oh, we have one more. We can cancel out the b's here and here, a numerator and denominator. b divided by b is 1. And it looks like that's all that we can cancel out. So everything left in the numerators are 6, and it's being multiplied to the binomial that's left in the numerator of the second fraction, which is b minus 8. And in the denominator of the bottom, we have 5 and b plus 3. So we'll put 5 and b plus 3. And those are where those two last ones that weren't canceled out with anything. So this is our final simplified product of the rational expressions, and we're all done.